My name is David Lutterkort. I'm going to talk about OpenNebula and Puppet for a little bit. That's me on Twitter and my email address in case I hear Bill Gates gives money away every once in a while for forwarding emails, so please include me in that. Also, if you have questions after the talk, you can contact me there. I work for Puppet Labs. Not surprisingly, we do kind of two things. We have a pretty big open source project called Puppet. You would have never guessed that from the company name. And we also have a commercial offering called Puppet Enterprise, where we bundle Puppet and some related open source tools together and have some proprietary add-ons, mostly UI related, and sell that with a support contract and all that. Puppet's been around for a pretty long time. We had our conference this summer, and Luke Canese, the CEO, the founder of the Puppet project and the CEO of Puppet Labs, actually talked about the last 10 years of Puppet. I hadn't realized it had been that long. I got involved with Puppet pretty early on in like 2005, 2006. But I've been at Puppet Labs only for about a year and a half now. I've done a few things in the past open source. One of them came out of my frustration with how Puppet managed or worked with configuration files and making changes in those configuration files. A little project called Augias, which is a way to programmatically edit configuration files in a safe way. If you're still doing that with set, grep, awk, those things, stop doing that and check out Augias. I spent most of the last year or so on something called Razor. And when I put these slides together, I realized that Razor is a project without a logo. So the picture down there is something that somebody in the community did that actually is supposed to represent Puppet and Razor together are pretty awesome. The proximate thing why I'm here is that before I joined Puppet Labs, I was working on a project called Delta Cloud, which goes back to kind of the happy days when cloud was even newer and everything was even more in flux than it seems to be these days. And what we tried to do was build a cloud agnostic API, one API to work against multiple clouds. That's also where I've heard about OpenNebula for the first time, because out of the blue, the OpenNebula guys, I think Daniel Molina, showed up and added support for OpenNebula to the Delta Cloud project. Back then, that was against the OCCI API that OpenNebula has, but I think these days everybody uses the EC2 API. Although Ignacio's slides seem to indicate that there's still quite a few of OCCI users out there, right in your survey. So the talk, I'll talk a little bit about just configuration management in general and what Puppet does, and then I'll go through a few examples of where the two intersect and how they enhance each other, and where using OpenNebula and Puppet together can really make things easier for you. So the first question is, what's configuration? Everybody, I think, has an intuitive understanding what they think of when they hear the word configuration. I recently came across a really nice definition by one of my colleagues, Gareth Rushgrove, that kind of struck a chord with me, because my intuitive understanding has always been more kind of the traditional, we push around some configuration files, what are the packages that need to be installed on a system, what services need to be running, that's configuration. But I think this definition is actually much broader and also reflects much better what people do with configuration. That configuration is anything that's input into your infrastructure. That becomes interesting when you start thinking about cloud, for example, where you would think of the virtual machines, the instances you're running in your cloud as configuration too, right? That's also something that needs to be managed and understood. So in the view, configuration management is concerned with managing these inputs into your infrastructure. And there's kind of two dimensions where that is important. For one is this management happens over time. It's really easy to set up something once and then just run it without any change, but that's not how things work in the real world. In the real world, you always have things evolving over time, and you need a way to keep track of the changes that happen and make them in a controlled manner. Similarly, the other dimension for configuration management is that this generally has to happen at scale. Again, it's really easy to manage 3 systems. You can do that manually, logging in, making changes, and you can keep everything in your head that's running on those 3 machines. It gets a little harder when you move to 30 machines. Once you have to manage 3,000 machines, without tooling, you're pretty much lost. And that's when emergent behavior happens, and you need to understand, how much your infrastructure actually agrees with what you think it should be, where problems happen, and all that. So in Puppet's case, the way Puppet supports or does configuration management, here's a picture of kind of the basic life cycle of how Puppet goes about doing its business. We have a Puppet master, a central server. There's different schools of thoughts in the configuration management community, but I think by now most of the tools rely on a central server, and that central server in a way is all-knowing. That central server knows everything there is to know about your infrastructure based on, in Puppet's case, that's called a manifest that you've written that describes what should be in all these machines. You, of course, have a number of nodes, and we have an agent running on each of those nodes. And the first thing that happens when this node needs to be configured is that it gathers facts about itself. There's a little tool called Factor, and facts are things like, what are the network interfaces I have, how many hard disks I have, and how big are they, how many CPU cores are there, what's the operating system running on the system, and all that. It gathers all that up, sends it to the central server. The central server, the Puppet master, goes through the entire description of your infrastructure, figures out what that specific node should be doing, compiles it into something we call a catalog, sends it down to the node. The node goes through this catalog, figures out how much its actual state agrees with what the catalog says, and makes any changes that are necessary, sends back a report. The Puppet master dumps that report into some storage. These days the storage is usually something called PuppetDB. We also store things like catalogs and facts, not just reports in there. And so over time, this PuppetDB becomes a really, really valuable piece of your management infrastructure, because you can ask it questions like, which systems had failures in applying their configuration? What sort of things that I describe in my manifests actually cause failures? Which systems in my infrastructure are running a web server? All these things you can extract from the central storage. So having this sort of centralized view is really, really valuable. The way you describe your infrastructure is in Puppet has its own language called the Puppet DSL. We're really good with naming, and this is kind of the prototypical use of a manifest. If you have this pattern down, you probably have covered 80% of what people need to do when they manage infrastructure with Puppet. What this says is, for us, a web server. When I say I want a web server, I want the HTTPD package installed. I want this one configuration file that the source URL down there in the file area says this is the file that it lives on the Puppet master downloaded. And once that file is in place, we also have to have the HTTPD service running and enabled, meaning when the machine reboots, it should come up. So none of that is particularly surprising. The important part, there's 2 really important things about that. One is, you might notice that there's no talk about how you actually install a package, or how you set the mode on the file, or what you need to do to start the HTTPD service. Puppet's approach to management is what's called desired state. So you express what you want the end state of your system to be like, and it's Puppet's job to figure out how to get there. If the HTTP service is already running, there's nothing to do. Puppet's happy. If it's not running, Puppet will figure out how to start it depending on the operating system that you run it on. And so in this manner, you kind of decompose the different things that machines in your infrastructure do into classes, into roles. Besides the web server class, you might have one that talks about NTP, right? Everybody likes to talk about NTP and how to configure that. And once you do that, you realize that there's a lot of similarities and a lot of differences between your systems. So you need a concise way to express that. That's one example of how you do that in Puppet. where we say the web server 2, role, class, whatever. It's pretty much the same as the web server, except we use a different configuration file with it. And there's other and better ways to do some of this, but this is the easiest one to put on a slide. There's things like a tool called Hyra that lets you look up data or set things based on complicated conditions based on facts of the machine. So since you've kind of decomposed what configuration means to you into these different roles, you need a way to assemble these different aspects of a system's configuration, NTP, and it's a web server or it's a database server. And you do that with these node statements here, where we say the host 1 is a web server and host 2 is this slightly different web server that we just saw. Host 3 is running a MongoDB server. I had to throw MongoDB in here because no talk would be complete without mentioning MongoDB. This host 3 is a MongoDB server. Again, this is not necessarily the best way to do it, but it's the easiest to put on a slide. There's in Puppet Enterprise, there's something called a node classifier. There's also open source node classifiers, which based on rules figure out, a machine that looks like this should be a web server, and a machine that looks like that should be a Postgres server or something like that. Which, especially in elastic environments like OpenNebula, is a much better way to go about it than these very fixed host name based classifications. When Puppet first showed up, kind of the almost revolutionary thing that it did was that it moved, that it talked about infrastructure as code rather than what people had been doing before, which was this here, infrastructure as Word documents, or if you're, if you were in a more agile shop, infrastructure as plain text files, or in enterprises, infrastructure as XML documents. But I mean, this was, and I suspect still is the case in a lot of organizations, that your infrastructure is described in some Word documents, and if you have to add a new server to your accounting system, you go pull out that Word document, read what needs to be done, and then do that fairly manually. The huge advantage of doing things, doing infrastructure as code, is that you can now source control the code, you can share that code with other people, you can collaborate on the best way to set up Postgres or something like that. For that, we have something called the Puppet Forge, which is kind of the central hub where you can find configuration descriptions that people have done. So if you're going to try out Puppet and you want to know how to set up Postgres or something like that, that's where you would go and look what's available. I mentioned Postgres because that's one of the modules that is really, really thorough and really well used and very usable. Okay, so much for kind of the general configuration management and Puppet part of things. I wanted to go through a few specific touch points between OpenNebula and Puppet for the rest of the talk, and I try to structure it kind of in a way that when you start falling out of the clouds all the way down into your data center and onto physical nodes. So we're first going to look at a few things that are really important for cloud users, for OpenNebula users, and then a few things that are important for OpenNebula administrators. By the way, how many of you have used Puppet? Anybody? Oh, okay. And how many of you are more on the OpenNebula user side? Okay, and the rest of you are administering? Oh, yeah, no, I meant just in terms of like OpenNebula usage. Would you consider yourself more an administrator of an OpenNebula installation or a user? Okay. Okay, so the first thing I wanted to look at really quickly is how you manage cloud resources from your Puppet manifests, which is where I think the EC2 API for OpenNebula comes in, because we just recently wrote something called the AWS module, which you can use with the OpenNebula EC2 API. And that module, it mostly talks about AWS-specific resources that don't necessarily all apply to OpenNebula. I think there's also some room for, if anybody's interested, for improving that module to make it work better with OpenNebula. But the most basic way to use it would be to describe an instance that you want to launch, which you put this in your manifest for a node, and Puppet will go and make the appropriate calls through the EC2 API to actually create an instance, so that you can manage the kind of the fleet of instances you have running that way. And I think most of the attributes of this are pretty self-explanatory. If you know the EC2 API, there's not much in terms of surprises there. So that now that you've got your instances running, the next thing is how do you actually manage what goes into those instances? How do you manage the web servers and databases, whatnot you're running in your virtual machines? And there's really not much that's different from using Puppet in any other machine. There's you talk about your content in there the way you talk about it for any other sort of machine. The one thing where you trip up generally is this little SSL thing there, because SSL is always the problem. The thing we need to be careful with Puppet is because the Puppet master knows everything about your infrastructure, which generally also means some secrets, like people, for example, manage the host keys for their SSH daemons with Puppet, or other kind of sensitive pieces of information. So we need to both to protect the Puppet master from rogue nodes, right? That if some node shows up in your infrastructure and claims to be XYZ, that it can't download sensitive information that it shouldn't get access to. So not only does Puppet use SSL with server certificates to kind of verify that the server is that it claims to be, each node also has to have an SSL client certificate, and that's kind of the thing where things get a little funky when you're in the cloud. The kind of general flow in Puppet is more modeled on on a situation that's where you have physical machines and new nodes show up very rarely. So we have a node that's got the Puppet agent installed on it, and when that runs for the first time, what it does is it creates a certificate signing request, an SSL thing, sends it to the Puppet master. The Puppet master checks that is a valid CSR from a node that it likes, and then issues a certificate. And after that, they're off to the races. The agent can talk to the Puppet master, get its catalog and all that, and everything's good. Where this runs into trouble in the cloud is at step 2, because the main way of checking has been that a human checks, right? If you're working with physical infrastructure where it takes 3 months to even get a machine online, that's not a big deal. If you're working in cloud where instances live for 15 minutes and come and go all the time, that's a big deal. So one of the things we've added recently is a better way to deal with this certificate signing problem. So if you look at what actually happens when you're in cloud, is that you have some OpenNebula client that talks to the OpenNebula API, which then creates the node, and then the node should talk to the master and all that. From the point where the OpenNebula client kicks off the instance creation, everything should be automated. And the way we do this is that first the OpenNebula client, and client here isn't just command line client, right? This could be another application that's actually creating instances. That the client and the Puppet master need to agree on a secret. And the secret can literally be some sort of pre-shared key that you share between the two. But it could also be a way for the client to tell the Puppet master, hey, I just launched an instance, be prepared that this machine will show up, right? And stick that somewhere. But in the case of a pre-shared key, you would have to arrange for the client that does the instance creation to pass that secret all the way into the node through user data or something. Then the node includes that secret in the certificate signing request. The Puppet master verifies the secret now. There's no human needed to actually check. And then we issue a certificate. And the part where you come in the most is the last, the verify secrets step, because you need to write a little script that actually receives the secret and verifies that that's okay. This auto-sign script gets on its standard in, it gets the certificate signing request. And we include secrets as what are they called? CSR extension attributes. SSL has a lot of fun words. So the way you set this up is that on the master you have to write this auto-signing script, and you point your master at that, so that when a new CSR shows up, it gets to check that. On the nodes, through like a little cloud init script or permanent instrumentation in your images, you arrange to pull the secret, the pre-shared key out of the user data and dump it into a specific file. And then when the agent runs it, it adds what it finds in that file into the CSR. And so with that, you have a fully automated way to trust, to have the server trust the specific node that you've created. There's a few kind of predefined attributes you can use for these CSR extensions, like the instance ID and of course pre-shared key. If you've ever dealt with SSL, nothing there is totally straightforward. In reality, these are OIDs, which are these long dotted decimal string thingies. And we predefined a few of them for the kind of the most common use cases, but there's also in that namespace there's room for kind of your private extensions in case these attributes don't make sense in your situation or in your security model. So you can pass your own stuff through there. Okay, so now we've got agents coming and going automatically. We can create instances. One thing that you'll find is if you create instances based on fairly vanilla operating system images, say you have a CentOS 7 image that has not much more than a Puppet agent in there, is that instance creation actually can be pretty slow, because the first time the Puppet agent runs, it gets told this is supposed to be a web server, so it goes and installs a lot of packages and starts services and all that, which we've got customers who complain it takes them 20-30 minutes before a machine is actually ready, before Puppet's done with its first run. So you might ask yourself, can I build images based on all this wonderful description of my infrastructure that I have on the Puppet master? And there's a few ways to go about it. I mean, there's a whole host of tools that helps you with building images. I don't know what people generally use, Packer, VW, one of those things, Aminator, I don't know. But the techniques I'm describing apply to pretty much all of them. One thing I highly advise is that you use the same sort of manifest that you use for running machines for your image builds, and you just invent some fake host names for the actual image builds. The image builds happen on some machine, but the name of that machine is completely irrelevant to what goes into that image. So just come up with some naming schemes that says, if I'm building an image for this sort of web server, I'm going to give it the fake host name webserver.images.example.com or something like that. And you try to split the configuration that you stick in there into two parts, where the more generic part goes into the image, and then the personalization, there's always things that are specific to one instance. You keep that separate, and that only gets applied when you actually launch an instance of that image, and pull that in. So there's two general ways that you can use Puppet to build images. One is during the image build, you run something called Puppet apply, which gives you basically command line client to the command line interpreter for Puppet manifests. The orange line is the one where you give the fake name for your image build. And that's one of the things I don't like about Puppet apply that much, is that you wind up downloading everything about your infrastructure into the image build, and if you're not careful to clean up after yourself, you have all that lying around in the instances you launch of that. But it's, as I said, using Puppet apply in that situation is really easy to set up, and you don't have to fiddle with any sort of Puppet masters or anything like that. The downside is that since you don't use a Puppet master, it leaves no trace. There's if things go wrong, can be pretty hard to figure out what went wrong. You have no entries in PuppetDB about that. You can't use a node classifier and all that. So yeah, if you first experiment with running Puppet during image build, Puppet apply is definitely the right thing to do. But for a more robust setup, I would actually recommend running the Puppet agent during your image build, because then image building looks pretty much the same as running a Puppet agent when you've launched instances. You just use a slightly different host name. Yeah, SSL gets in the way again, as always. There's two ways you can get around that. One is, for each sort of image you want to build, you pre-generate yourself SSL certificates, copy them into your image builder, and use those. Or you go through what I just described with the certificate signing, with automating certificate signing, and do that during your image build. The one thing you have to be careful with is that if you repeatedly build the same image, the Puppet master freaks out when it gets a request for a certificate for the same host name it's already issued. It'll say, no, I don't want to do this. So there's a little setting you have to make on the master to enable that. Okay, so we've got images. That's kind of the user part of what I wanted to talk about. From an administrator's point of view, there's a few things. The first one is, since OpenNebula is an application that runs on a bunch of physical machines, what can you do to manage that with Puppet? And there's actually a really nice module written. Is anybody from the ePost here? Because I had nothing to do with this module, but I discovered it and thought it was really nice. Oh, later? Okay. Yeah, I wanted to talk to them about that. Yeah, it's a very nice module that lets you describe all the basic entities that make up an OpenNebula installation in Puppet, and the module then goes and calls out to the various OpenNebula tools to do things. It's got there's an OpenNebula 1 class, I guess is how you would describe that. If you include that on a node, it actually installs OpenNebula for you. It installs the OpenNebula master and Sunstone and all that. And then there's various resources to describe. They're all named the same as the command line tools: one host, one image, one template. It's pretty obvious what they do. But with that, you can describe all these things in your Puppet manifest. Unfortunately, that module is not on the Forge. That's one of the reasons why I wanted to talk to the ePost guys, because I think it should be. It would be a great enhancement. In general, I think there's not very much collaboration between the Puppet and OpenNebula community, and I'm hoping that by being here and talking to people that we can get more of that going. I would love to see this. Not just on the OpenNebula module, not just available on the Forge. We kind of have 3 tiers of modules on the Forge. Like, anybody can add a module, and that's great. If you write a module, absolutely you should add it there. There's also something called Puppet Approved, where we go through existing modules, because it's sometimes hard to tell how good a module is. And for some things, there's like 15 modules. When you come to the Forge, it's really hard to figure out which the right Tomcat or MySQL or whatever module is. So with Puppet Approved, we're actually going through the Puppet code that makes up that module and try to figure out, or require that it meets certain standards, certain coding standards, and certain amount of activity behind it and all that. And I think this would be a great addition as a Puppet Approved module. Okay, and so the final thing I wanted to talk about is, because behind every cloud there's a lot of actual physical hardware. It's something that people like to forget, that if you run a cloud, you have to deal with provisioning physical machines, for example. And as I said in the beginning, I've worked for quite some time now on this Pixie provisioning tool called Razor. Funnily, Puppet Labs actually didn't come up with Razor. It came out of EMC, EMC VMware. Was started by 2 guys, Nick Weaver and Tom McSweeney, and the reason they started is they had a problem that should be very familiar to any OpenNebula admin. They wanted to roll out clouds and manage the hardware and provision the hardware that was running their cloud. Of course, they're they weren't using OpenNebula, they were using vCloud, but I mean, the basic ideas apply here. And so just in a nutshell, there's three things I really liked about Razor that struck me as really good insights into how to deal with PXE provisioning. If you've ever dealt with PXE provisioning, it's a really horrible thing to do. But yeah, the first insight they had is they use a firmware called iPXE. I don't know how many of you have seen or used iPXE. The nice thing about it is it's a firmware that you can script. It has a very simple scripting language. The second thing that's really nice about it is it can talk HTTP. And I don't know if anybody who's ever implemented a dynamic TFTP server, which you would have to do to get interesting behavior out of PXE. But we all know how to write interesting web services. So by using iPXE, they kind of elevated PXE provisioning from something that's done with stupid files lying somewhere to something that's backed by a web service. The second key insight they had is to use node discovery or inventory nodes before they actually install them. And so Razor builds a hardware database over time as more machines come in there, and can make a lot of decisions based on what your hardware actually looks like. And the last one is something that's probably a little more subtle. There's kind of two kinds of PXE provisioning tools, the ones that do too little and the ones that do too much. The ones that do too little just install stuff and they're like, okay, we're done. Nobody would ever need to manage the machine we just installed, right? We just lay down bits and that's it. And that's clearly too little, and that's what the kind of second kind of tools realizes, and they're like, they realize that you need to configure machines too, besides just laying down bits. And so they sprout all this fairly random configuration management functionality, but that's completely the wrong place for it because your provisioning tool only touches your systems once. And so Razor tries to be kind of the Goldilocks of PXE provisioning tools. Don't do too little, don't do too much. And the way it does that is that it tries to hand off the provisioning process as quickly as it can to a config management tool. We generally use it with Puppet and Puppet Enterprise, but it's also got support for Chef. Somebody contributed support for just laying down CoreOS installations. I think if you're using Puppet and OpenNebula together, it's you can just use the existing bits to have it roll out OpenNebula compute hosts, for example. But if you don't want to go the Puppet route, you could also customize Razor fairly easily to install OpenNebula compute nodes and enroll them directly with your OpenNebula master. And so just in a nutshell, how it works, just to go through how it works really quickly. When a machine boots for the first time, the iPXE script that we have, when you install Razor, there's two things you need to put on your TFTP server. One is the iPXE firmware and a little iPXE script that we give you from the Razor server. And once you've done that, you don't need to touch TFTP anymore, or any of that kind of PXE setup is done. Razor also doesn't make any changes to that. It's all done through HTTP as a web service. When a node boots for the first time, it runs this little iPXE script, which really doesn't say much more than go talk to the server over there to figure out what you should be doing. If it's the first time that node boots, the server says, hey, I don't know you, we should get to know each other, and sends down what in Razor speaks called a microkernel, which is a terrible misnomer. It's really just a Linux image, a small Linux image that runs factor, the same factor we use in Puppet, and sends those facts back. So now Razor knows, oh, this is a machine with these many CPU cores, this much memory, this much hard disk, network interfaces, all that stuff. You can also extend this fact gathering process to figure out things like, oh, this machine is plugged into this switch, or it's at this position in a rack. And then based on all that information, you've set up rules and tags. We go through those facts and figure out which of those rules you set up. Machines with more than 8 cores should be called large. Machines with more than 64 gigs should be high memory or whatever. machines that are in the bottom of the rack should be labeled bottom of the rack. And with that tagging, we go into something. You also set up a policy table that basically says a machine that's tagged in the following way should get CentOS 7 installed on it, should be a database, and if it's tagged in this other way, it should be an OpenNebula compute host. So that you can set up things in a way that all you need to do is turn on a machine, and everything else gets provisioned afterwards, very simply, very flexibly. You can also say, the first machine that comes by and looks like this should be my OpenNebula master, and any other machine that looks the same but should be an OpenNebula compute host. There's a lot of the rule language is actually pretty powerful, and lets you make a lot of decisions on what winds up on machines. And so the policy also talks about what should actually be installed on there, and it rattles. Once it applies to a node, it rattles through the installer. And unfortunately, this graphic has Windows on it. But you can also install Windows with Razor. But I think for here, installing the various flavors of Linux is probably more interesting. Okay, I'm not even going to go. Let's just skip that slide. Okay, so just quick summary of what I've talked about. If you write if you're using Puppet or write any Puppet code, the forge should be your first stop to see what's out there, or to tell the world what you've done. The AWS module lets you create, manage what instances you have running through the EC2 API. This whole cert signer business automates the process of getting a cloud instance actually up and running and enrolled with Puppet. EPOS Dev lets you manage the the administrative entities that OpenNebula deals with. And then if you're in the market for a provisioning system, Razor's your friend. And with that, other questions? You install, sorry? Mm-hmm. Yeah. Mm-hmm. 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 Yeah, so I mean, the example I had was very, very simplistic, just to make it fit on a slide and be able to talk through it. In reality, a lot of these classes take a lot of parameters, and so you would, I haven't actually looked at the Apache module, but I'm pretty sure one of the parameters you can set is what's the file with my SSL certificate from a web server. And you would, when you on a node, when you say this is a web server, you would say this is a web server using this SSL certificate over here. And then on another node, you might set up a web server, but it uses some other SSL certificate. Anybody else? This is a very... Yeah. So I have to take some of the blame for Cobbler, because at the time I was actually working with Michael Dahan when he wrote Cobbler. And when I first, to be honest, when I came at the Puppet Labs about a year and a half ago, and they're like, we have this Pixie provisioning tool. You should look into getting this kind of into a product or production ready state. I was like, have you guys checked the calendar? And I actually went back to, who does Pixie provisioning anymore, right? Was my reaction. But I went and looked at Cobbler again, and then compared it with where Razor, even at the kind of CTO level code it was when I came on, was, and Cobbler just felt really, really dated. In it's XML RPC. The model is it falls definitely into kind of the second bucket of Pixie provisioning system, where it's trying to do some configuration during provisioning. So I'm not hugely bullish on it. No comment. Yeah. I mean, clearly, I think Puppet is much better. Otherwise, I wouldn't be working at Puppet Labs.
That's the religion question you shouldn't ask anyway.
Yeah. Okay.
Thank you, David.
Thank you.